Alright. What is up, guys? We're back. Hey, what's up, guys? My name is Eterno. Welcome back to the end of Vulkan Week. It's incredible. I mean, it's the second half of the last day, but it feels like it's the beginning. Let's get that music back in. How's everyone doing? I'm keen to get this over with. Not because I'm not enjoying it, but just because I feel like we've done so much this week. Again, as I mentioned, never done this much. I don't think I've done this much programming in a week since I quit my job at EA. But yeah, we are in fact back, and let's go straight into the code. Let's not waste any time. So what do we stop with? I think, was everything working at the end? Oh, no, it wasn't, because that's right, we were only going through a single shader. Like, we were only going through the vertex shader, we need to go through both. So, that's fine, and then that's fine, and where is the actual reflection code? This, right? Reflect, okay. So, inside the reflection code, we need to make sure that we have a way to reflect over both, I guess. So okay, again, I don't want to waste too much time rewriting this stuff. So because of that, but then again, let's just think about this. So push constants. What happens if we have push constants in both the vertex buffer and the shader though? Sorry, the vertex shader and the fragment shader. Because let's just check this out, right? There's no push constant. Yeah, okay, uniform push constants here, right? And then there's got to be another one here. There is another one here. Ah, offset is 12. Interesting. So it looks like, yeah, they're still set automatically, right? Because this vec3 has no layout, so I'm assuming it's the offset 0, right? And then this has an offset of 12. 12 happens to be the size of a vec3. So that's interesting. So that therefore it still is the same push constant. It's just that it's across two shader stages. Very interesting. Do we still... How does that get set? I don't know if that's like the correct way to do things, or if that's... I don't know what people do. Thank you guys for the welcome backs. Yeah, I'm not 100% sure if that's like what should happen. But okay, so push block, what's push block? But see, that's different. Why is that different? Oh, that might be for different stage. So therefore we should probably look at different stages, like here for example. Ah, okay, so here we go. So to vertex and to fragment we push them differently, and then obviously in this case I think we go material push block, which contains only the material stuff. Interesting. And then what's this? There is an offset, and yeah, he's actually setting the offset manually like that. Not 100% sure. Lunch was good, thank you. Breakfast, I had like nice eggs and avocado on a naan that I made. Really good. And a coffee. Oh, my coffee. I forgot it. I didn't finish it. I found it. Thanks, Meta Potato. Okay, so Yeah. So okay. Well, let's not get ahead of ourselves too much here. We'll reflect and yeah, I think we should probably do the reflection over one piece of shader data, and then we can do that appropriately for the shader stage, right? So let's make that happen, right? So we'll do, and then I guess there's like a shader stage. What is that? Shader stage flag bits. So we have a stage and we have the data for that stage. So based on that, I think instead of this being all like, I mean, I don't think we can have sampled images in vertex buffers. I don't know, maybe Vulkan supports that. Sorry, in vertex shaders. Keep saying vertex buffers. I don't quite remember. Maybe someone can help me in chat. What am I looking for? I'm looking for this stuff. The stage stuff. So the stage flags are always going to be shader stage, right? And that way we shouldn't have any problem here. That's it, I think. Right, so that was shader stage, all right. So now what we do is we can reflect on the vertex buffer, which is VK shader stage vertex bit. And then we do the same thing for the fragment as well. I'm really interested in seeing how that works out. So let's put a breakpoint here and run this. Alright, so let's check this out now. So we've done a reflection over both stages. So we have 2 image samplers, 1 uniform buffer. I guess this did work then, because that seems pretty good. And the image samplers, so there's one at binding point 1 and one at binding point 2. Perfect. I guess that's good. So now we're going over both, and if we just hit F5, maybe it will run. Nope. We get an error. Shader uses attribute slot 0, but it's not accessible from stage vertex bit. Alright. Let's see where that's coming from. Vulkan pipeline invalidate. Yeah, so this might be us just not setting it up correctly, right? Actually, hold on. So we're getting the descriptor set layout, right? And the push constant at the moment we're saying, like this part is like, you know, a bit of a to-do. Should come from shader because like, you know, actually push constant range. I'm curious as to where he sets that up. So there's 2 ranges. Okay, you can have 2 ranges. So one range is from 0 to 12, which is the vertex one, and then from 12 to whatever the size of that push block is, that's the second range. And I guess he just has 2 ranges, which is how you get the and where do those ranges go? Yeah, there they are, into the pipeline layout create info. Okay, cool. That makes sense to me. Now we at the moment our push constants are we're not really worried about that. So I'm actually kind of surprised that that didn't work, to be honest. Let's see if we can look at this though. So we've got none in there, but we should have, images don't show up yet. And then push constant, we have 1, and 1 uniform buffer as well, binding point 0. Yeah, why did that not? Kind of surprised that that didn't come up actually, to be honest. Fragment vertex. We do that, right? Stage. Fragment and vertex. Shaded out 0, 1. Reflect, we run twice. Does that do anything bad? No, shouldn't. And then are we still doing everything as needed? Ooh, no, that's not gonna work, sorry. This part we still have to do once. My bad. So this part we do twice because we need to find all of this stuff, and we also need to know what stage they're at. So yeah, that's just my bad. Alright, so that means that VK shader stage flag bits. I'm gonna restart Visual Studio just because I haven't done it yet and this is just running so slowly. Hopefully that fixes it. Yeah, we're not doing ray tracing anytime soon. It's gonna be a while. But this is paving the way for future ray tracing, hopefully. Alright, I don't know if this will be any faster, but it would be nice if it was. Why is that? Okay, whatever. So hopefully when we go through this, we can, if we find a uniform buffer, we have the opportunity to actually set the shader stage to the stage that we're at. And then same for the image sampler, although again, vertex, you know, image samplers inside vertex shaders, not sure if what the deal is with Vulkan supporting that. I think it might, but I have to, I would have to check. Jay Cowley, thank you for your kind words. My pleasure. I love doing this kind of stuff. So I'm glad that you benefit from it, for sure. I think that should be good now. So now that we've done that, we can actually like set up descriptors and stuff, right? So let's do that here. So void setup descriptors. Or create descriptors, I don't know. We'll do create descriptors. Electron diffuser, welcome back. Descriptors, all right, here they are. So this now we should be able to just chuck in here, right? And then it's gonna do it once for each thing. Now, yeah, this should now come from the uniform buffer. Just like this should come from the image sampler. Why are you sad? Device is undefined, that's fine. Steal that. Oh, let's fix this horrendous formatting. All right, and that's that. So now if we do instance create descriptors, maybe that works. Yeah, learnopengl.com is a pretty good resource, I think. If you're new to graphics programming or you're new to 3D, meaning you still don't understand how all that stuff works, then I would definitely start with OpenGL instead of like Vulkan, you know, and maybe just because there's no reason. Like, I still kind of argued the fact that I don't think there's any reason for a like small time, we'll say, developer or a solo developer to just go with Vulkan. Like, the reason you pick Vulkan is either you're really interested in rendering and graphics and you want to do all of the latest and greatest stuff, and you want to like take a look at research papers and implement like ray tracing and other like really advanced concepts, or you simply have the resources. Oh, this works, yay! Or you simply have the resources to do it. Like, as in, maybe you're a small studio, but you've got like a couple full-time engineers maybe, and they like graphics and they want to do Vulkan, like whatever. But if you're learning, like, if you exclude ray tracing, I don't think that Vulkan would bring you much benefit. Obviously, Vulkan can perform a lot better, especially if you multi-thread all of your rendering and creation of command buffers and stuff like that, for sure. I don't doubt that. But the thing is, for most things that solo developers are probably rendering, again, if we exclude the ray tracing and stuff that you just can't do in OpenGL, then like OpenGL is still a pretty good API, and it can render like, you know, what you want it to render. Like, there's no, it's like recommending someone to go to Vulkan is actually kind of difficult. Like, you know, it's kind of like if you're into DirectX, like DirectX 11 is great. There's no reason not to use DirectX 11. It's supported by more platforms. It's really easy to use. It's really nice. It's a beautiful API. Whereas DirectX 12, it's like, well, if you want the low-level stuff, and if you want to really squeeze the performance out, and if you want like more control over the GPU, and you want ray tracing and stuff, then go with that. But it's not like 11 is just disappearing. So I would for sure recommend starting with OpenGL. But what do you mean you want something faster than OpenGL? Like, I mean, I wasn't like rendering huge scenes, but I had a scene rendering in OpenGL, like with PBR, and you know, I've rendered some pretty more advanced things. I don't even have like frustum culling or anything like too proper, but like the shader complexity isn't like that high, especially not like without me doing shadows and a billion passes and stuff like that. But I'm getting like 0.5 milliseconds per frame, like with animation and everything. I just don't understand, like, you know, what's the deal with it, you know? I still think, I don't know, I think people like to hate on OpenGL, and I don't like OpenGL that much, and I don't like the API that much, but if I had to make a business decision to go to Vulkan, that, like, you know, issues aside, OpenGL is a lot easier to deal with, and there's no problem, you know. Again, if this is just a hobby project and you're really interested in graphics and rendering, then for sure Vulkan is probably what I would pick, for sure. But I'm just talking about more for people who are new to like graphics and stuff. Like, Vulkan is gonna make them hate graphics, I think, because it's just like, it's ridiculous, you know. Unless they're like really good programmers maybe, and they've had experience with large code bases, that could potentially like be fine, because then maybe they wouldn't be scared. But the thing is, the nice thing with OpenGL is usually people are quite new to C++ or program. Well, not necessarily, obviously, but let's just say the person is new to programming and they're really interested in graphics. OpenGL is very small. Like, there's not much code to write to get like a triangle up, or, you know, once you have like some code to compile shaders, for example, it's pretty easy to, you know, to render a 3D model. But with Vulkan, that's going to really confuse people who are new to programming, maybe, because like, I mean, even people who aren't new to programming, just because of the sheer amount of code that's happening, like, it's difficult to navigate that if you're not experienced with programming, you know? Yeah, like Electron's saying to learn Vulkan to beginners is like saying you can jump out of a plane without a parachute, but you can do it only once. I'm not sure how that metaphor adds up, but yeah, I mean, it is pretty crazy, is the point, I guess. It's a fancy gun. Yeah, it's not a bad gun. This is yeah, there's like 0 MIP mapping going on as well, which is fun. Actually, maybe we should sort out the MIP maps, right? But there's actually a normal map here as well, so we're using 2 different textures, which is good. Yeah, exactly. It's like giving a 100 by 100 Rubik's Cube to someone who can't solve a 3 by 3. Maybe not 100 by 100, maybe more like 10 by 10, but yeah. Anyway, now that we've got this compiling and working, let's take a look at Vulkan test layer. Yeah, we should probably take a look at MIPS, I think. I mean, because I'm just creating one MIP at the moment. Now, does Vulkan actually do MIP mapping for you, or does it want you to provide all the MIPS yourself? Or can it generate some MIPS for you? Because for like normal textures, I don't really care about generating my own MIPS. Obviously for cube maps and environment maps, we do actually generate our own MIPS using a compute shader in Hazel. But that's because we want really nice buttery blurs for lower MIPS. You need to generate it? Oh, that's so annoying. I guess I should have expected that though. Is this a thing that is texture MIP map gen? Alright, this is probably... I would have thought he would have used a compute shader for that. Maybe there is a way to just have it be done for you. Generate the MIP chain. Oh, okay. Oh, you do it, but you don't have to actually do it, I think. Yeah, there's still like linear filtering and stuff. And without MIP and with MIP mapping. Okay, 2 samplers. And then how does it do that? It just... Yeah, okay. It just copies them down. Okay, that's fine. I thought you had to like run it through a compute shader and do the filtering yourself and stuff. But it looks like it can do stuff like this for you. I've got a schedule. This is to AO Delta. I've got a schedule. Twitch.tv/the/schedule is my like schedule, right? So that's probably the best place to see when I'm live. I did take a 1 hour break just then, and now I'm back. So obviously that doesn't include breaks, but yeah. I also tweet about it, I guess. I also think Vulkan tutorials are backwards. There is no way people are going to hang around for like 900 lines of code to see a triangle. If I was going to do it, I would just start with a project that is already rendering a triangle and just step through it, explaining the info structs. That would also let you change settings to show people what they do. Yeah, I mean, I agree, but you know, I guess tutorials in the traditional sense are about like, you know, going from a new C++ project with 0 Vulkan code, maybe just a window, to like, okay, how do we use Vulkan from the ground up to render something? It's just that it's pretty unfortunate that that's kind of difficult to do. But like, I also think that if you want to use Vulkan, that's kind of what you should care about. Like, you should care about how the swap chain works and how, like, you know, the device creation or the physical device retrieving works. Like, because if you don't, then, you know, what's the point if you know how descriptor sets work, but you have no idea how the swap chain works? If you get a crash in the swap chain, then you're gone, you know? So I think that, yeah, I think that if you want to learn Vulkan, you should, like, the reason should be because you want maximum control over your GPU, and therefore you should care about setting up a swap chain and getting all the devices sorted out and like getting all the Q families up and running, because you care about how the GPU works. If you don't, then use OpenGL. That's my reasoning for it. But I definitely see where you're coming from. Yep, there's that schedule. Cool. Thank you, Kadia, for linking that. Okay. So let's quickly check out texture, because I was doing something here for MIPS actually, but I don't know what this was, to be honest. Let's quickly launch this example. Okay, so we can see that. Scrolling goes side to side. Okay. I guess we could probably ignore MIPS for now. I'm just wondering what to do because I've only got like a couple hours left. What should we do? I mean, I guess I'd like to get like a scene up and running. Cube textures as well and compute shaders would be nice. Where are the compute shader examples? Because I have no idea how Vulkan compute shaders work. I've never touched that stuff before. Command buffers, does that do stuff? No. Compute command buffer, okay. Pipeline bind point compute, and then we do command dispatch with. So it's pretty much the same, as far as I can tell. How do we actually create the texture compute target? That's not it. Here it is. Type storage image. Anyway, what is this example anyway? What does it do? Haven't done ImGUI yet. I'm probably going to do ImGUI last, because once we have ImGUI, we'll have more problems. Oh, this is weird. This resizing is odd. Is this being generated with a compute shader? Yeah, I guess it is. Emboss, edge detect, sharpen. Okay, cool. So I guess it's actually running the compute shader every frame. It's pretty fast. Anyway, how did you deal with VK pipeline layout? I don't know what you mean by how did I deal with it. Oops, that's not my code. I mean, I don't think we're like, yeah, push constants should come from the shader. I guess we should fix that now, maybe. The thing is, we need to make sure that we have, yeah, different push constants for different things. Like, because you can have two push constants, or you can have different push constant ranges if they're across different shader stages. But, you know, this should come from the shader. Basically, we should just ask the shader, hey, can you please tell me your push constant ranges, right? What shader stages are they in, what's the offset, what's the size, that kind of stuff, which we can get from shader reflection. And then, that's it. Is Hazel creating an object map for rendering scenes or using pre-written code? I don't know what that means. Creating an object map for rendering scenes. Shader reflection is us looking, basically inspecting the shader code to see like what it is, so that we can see like what the uniform buffers are, what the push constants are, what the image samplers are, all of that kind of stuff. Anyway, let's maybe make push constants come from push constants. As in like, yeah, we should have that here, so I'll do push constant range. Because we can have multiple of these, so we'll have a shader stage. We'll have an offset and a size, right? And I'm not 100% sure how we can get this stuff going, but we'll see. Oh, CXGS Legend, thank you for gifting that sub to Shazer HD. So for push constants, we can just push back. Well, we'll do and place back. The offset, I guess we would have to like do something like if push constant. I don't know if this is a good way to do it, but if push constant ranges size, then we can basically say offset equals the size, the size of the previous one plus the offset of the previous one. That way, technically, we would get the correct offset, which we can then give to that. All right, so maybe that would work now if we go back to the shader, and I want to test this across shader stages in a minute, but if we basically had a get push constant ranges, and then in our pipeline we can just do that, and then we can create these, right? Good name there, Chono. Guess we could probably have the shader generate this though, shouldn't we? Actually, yeah, why are we doing this? Why are we doing this here? Not sure I know why we're doing this here. Whatever, I'll do it this way, but for now, but like, yeah. Seems a bit weird because we're just copying data for no reason. It's like the same struct. Look, literally. It's the same thing, and that's it. And then we obviously take our push constant ranges dot data, and this is the Vulkan ones. So a little bit weird. And then dot size. Okay, and that should be that, right? So if we take a look at this quickly. See, this is really easy to debug, by the way. I want to just mention this to everyone watching. This is a good way of doing this kind of stuff because I'm working with one object being rendered. I'm working with one shader in the whole engine, right? I've disabled everything. So there's never a question about, oh, which pipeline am I creating? Oh, which shader am I? No, there's one of everything. You know, everything is ready to go. I just hit F5 and in seconds I'm already in the place where I want to be, right? Easy. If you start trying to do it all at once in a huge engine, it's gonna take a long time and it's gonna make you very frustrated. All right, so this should actually be perfect, right? And now let's try and tint this with a color. Okay, so I'm going to go into my shader, my Vulkan triangle shader. Ah, you joking? Okay, that's weird. Into my Vulkan triangle shader, and I'm actually going to add this push constant here, right? So we have another push constant. We'll call this, does it have to be called the same thing? I'm not sure. It doesn't matter though. So we'll do vec for color, and I'll do layout offset equals 64 vec for color, right? And then this color is, I'm going to basically multiply text color with that color. So we've got a little bit of a tint effect going on, and that should be it. So now if I go into my cached shaders, sorry for being weird, and delete that, now I should be able to just push my second push constant, which is where? Which is here. So there's push constants, then we do the second one in the fragment bit. This time with an offset of that and a size of glm vec for here, and then the values are going to be color. glm vec for color equals, guess we'll tint it pink. That should be pretty obvious, right? And if my calculations are correct, then that should be perfect. Do you intend ever doing any kind of unit test integration system? I'm not a huge fan of unit tests for game engines, just because it's, I don't know, because I come from a graphics background, and unit tests, like, you basically need to have visual unit tests, right? So you can actually write an image comparison thing where you output a frame from your engine, and then that way on continuous integration or something, you can actually test that. Anyway, that's working perfectly. Good, so we have tinting, we have push constants across shader stages working flawlessly now. Amazing. But stuff like continuous integration, right? For sure. That should be, the only reason that's not currently in Hazel is because I'm lazy, right? But for like Google tests and for unit tests, I don't think I'm gonna do that. Just because testing takes a considerable effort from the developer, and again, as a solo developer, I just can't do that. I'm not completely against unit testing, but I think that it's very difficult to do in a small team. And I know that it will provide benefits, but I don't think the benefits are worth it. So that's my deal with unit tests, right? So ad hoc testing is great, obviously. But integration, yeah, for sure. Like CI, continuous integration, for sure should be here. There's no reason not to do that. It doesn't take that long to set up. I could probably spend a day just setting that up, making sure it works, and maybe even doing basic runtime tests. And something even as simple as like, hey, please open the Hazel default scene, take a screenshot, or take that frame buffer output, and compare that against the last commit's output. And that way, if something breaks in the rendering or if something breaks in the application, then you know that like, oh, it crashes on launch, or oh, for some reason the frame buffer is black now. That's really easy to do, and you don't need unit tests for that. You just need to write a very basic testing like system for that. You just add support for that into the code, right? But yeah, anyway, that's my take on it. I think towards the end, because I worked on 2 different engines at EA, towards the end of our kind of smaller engine, we did start writing unit tests for the tools. It's like for the level editor and stuff, because that was written in C#. It was a little bit of a pain. No one on the team really liked it, but it did catch some things, I guess. But I don't know, to be honest. We're such a small team, and I don't know. I feel like you usually catch that stuff in your normal testing. Not to mention we did later get QA. I think we had 3 or 4 people on QA towards the end. Yeah, everything that touches the GPU is super annoying, for sure. Okay, so yeah, that's pretty cool. So we actually have 2 here. So can I call this like something else? Is that gonna compile and run and stuff? I only do CI for the pretty badges. That's nice. I guess CI, I guess that works, right? They're getting you to do CI just because of the pretty badges. It's nice. I did an entire video for Linode on CI, like a sponsored video on my channel a while ago. And like, yeah, like that's definitely, like, I agree with everything I said in that video, obviously, but I just haven't got around to doing it in Hazel. I really want to. It's just that, like, you know, so much stuff, man. And the thing is, I have to think about, like, I'm a content creator as well. I'm not just a software engineer. So because of that, I have to think about what's more exciting, Vulkan Week or Continuous Integration Week. And I think you guys know the answer to that. All right, I'm pretty excited with this, actually, because let me just quickly check, whoa. Let me quickly check the log. Oh, it's gone. I was gonna say, to make sure we don't have any, like, Vulkan errors or anything here. I don't think we do, though, because it would have... I've got a breakpoint in that debug print thing, in the validation layer printing thing. Why does this take so long? Is it really? I guess it's loading the textures. But goodness me. It's also doing some of the reflect. Nah, but we've got cached shaders, so it shouldn't be doing that. That's very, very strange that it takes so long. It must be the textures. It must be STB image loading the textures. What do you mean the pipeline? How do we... I don't know what pipeline you mean. The actual Vulkan pipeline? How do you cache that? Like, offline. Anyway. So what do we want to do now? I guess we should probably take a look at this, right? And think about how we're going to deal with this stuff more realistically, right? Because this is, well, I mean, look, realistically though, this whole build command buffer, this is the renderer. This right now is our renderer. This is what moves into the Vulkan renderer class. It's just that at the moment, obviously, it's just dumped here because we're in Vulkan test layer and it's just easier for us to test here. But technically speaking, it should be here, and you can see that happens on every update. Now we can obviously have this respond to like what we do. Oh, okay, here's something we should do though. Obviously, like, this whole pipeline needs to be cached, I think. For sure. So that pipeline cache, does that let you like load cached binary pipelines or something like that? I thought that was just like a runtime cache, because if you're creating the same pipeline over and over again, that's obviously you don't need to do that. Oh, you can save it to a file. Ah, cool. I didn't know that. Nice. All right. Well, that's something that we can do as an optimization later. But is that really taking that long to create those pipelines? Excuse me, my voice is weird. Oh, what's this actually? All right, so this descriptor set is what all of this should be inside the mesh, right? But how are we going to abstract that for different APIs, right? So, descriptor sets, eh? Okay, so what do we need to do? So we need to basically find out from the shader, you know, we need to, what's in the pipeline here? Is anything in the pipeline? No, it's just shader stuff. All right, so we need to find out what material is being used for what mesh, or for what submesh. And I guess each submesh needs to have a descriptor set, I guess, and a pipeline. I mean, I'm sure you could sort it and stuff, because like, and also these descriptor sets in this pipeline situation, right? Can we have a different like descriptor set per mesh? Like, could we do this here? Like, is that a thing? Thousand bits. Thank you, Jay Gra. Thank you for the C++ series on YouTube. You've been a massive help to my development aspirations. You're welcome. Glad you enjoyed my C++ series and my videos. Just want to see if this like runs. I mean, I guess it will, right? I'm not really sure about the order. Yeah, that works. So what about pipelines? I think we need to bind a pipeline before we bind descriptor sets, but I just want to see if this stuff, if we can do this stuff before the other stuff. But then I'm going to try and test it with something else to see if it works as well. With something that actually has more than one submesh. All right, so I'm kind of convinced that maybe it is working, but let's do test scene.fbx. So that has 5 submeshes, right? It's got like a sphere, a triangle, or a cone rather, a cube, and well, 2 more cubes, I guess, that are walls and a floor. So does this work? Yeah, it does. Cool. So obviously it's rendering like with the other textures and normal maps, but good. So what I've kind of maybe proven here is that it's possible to bind a single vertex and index buffer, which would represent our entire mesh file, like the entire FBX file. And then it's possible to draw submeshes with different descriptor sets and pipelines, which means that we can create a pipeline and a descriptor set per mesh where required, right? Because, or per submesh, because it's possible obviously to have, well, because each submesh is a draw call, so it's very possible to have like, if you're drawing a car, you know, you can have like the car body, which is like a car paint shader, and then you can have the glass, which is a completely different shader, completely different material, and thus it needs a different pipeline and a different descriptor set. So, that's my reasoning for that stuff, right? So let's try and do that. And then obviously, like, if it is the same, like if we know that it's the same, then we can just have the one pipeline that we reference. And we could have our own little Hazel pipeline cache as well that tries to cache stuff offline. But also that way we never, like whenever we create meshes, we don't have to create pipelines. If we already, because you know, the standard like PBR renderer in Hazel is going to be used for most things. So if you're loading if you're loading 50 different meshes, but they all use the same shader, then they can all use the same pipeline most likely. They just need different descriptor sets. So that obviously needs to exist. So much stuff. Anyway, I think what we're gonna do, guys, is because this stream I'm gonna wrap it up in a couple hours, I think, maybe in an hour. What we're gonna do is I'm gonna continue streaming once a week at least, which is what I was doing for like, well, before Vulkan Week, which is just the Hazel development, the Hazel dev like development streams, right? So I'm gonna keep doing that, but we're gonna keep Vulkan Week going. We're just gonna keep working on Vulkan stuff. Because obviously we're not going to finish this in Vulkan Week. I didn't think we would. I hoped we would get to this stage in Vulkan Week. I hoped that we could basically iron out everything as well as learn Vulkan really well. And I feel like we're Like, we haven't done everything, obviously. There's still a lot of concepts to learn, but I think I more or less understand everything. And I definitely have a clear image in my head as to how to get a Vulkan renderer up and running for this kind of stuff, which is really good. But then, yeah, so but I definitely want to keep working on this and polish this a lot more. And also OpenGL compatibility is obviously important as well. So, okay, and we're not doing any of the material stuff just yet, which is fair enough. Animation is something we need to think about, although animation is shader stuff. Like, who cares, you know? We just need to be able to set a uniform buffer with bones, probably, and then just, you know, use the animation shader and everything should be fine, I think. So that's good. Now, yeah, this stuff as well, like, so vertex attribute layouts. So they should be in the pipeline. That should not be, well, they are in the pipeline actually right now, because the way that we do this is, as you can see, we create a pipeline specification with a layout, and then we create a pipeline, which, let's do this. So let's start moving this stuff across, right? So from Vulkan test layer, where do we actually create the pipeline? So we're creating our own pipeline, I believe, here, with Vulkan triangle. So I don't want to do this anymore. I want to, instead of doing this, and what are we doing? We're just doing the, okay, let's grab this shader. Oh, we're probably not doing a render in it. Okay. The thing is, though, as I mentioned, we probably need one of these per, not necessarily per submesh, maybe per material. Because a material is a material, right? Like, it's the same material. So we probably need a pipeline per material. But I'm not sure how that's going to play with the vertex layout. Anyway, so this should work the same way that it worked here, right? And again, I should commit. I keep forgetting to. But anyway, this doesn't need to exist anymore. This doesn't need to exist anymore. Let's clean up some stuff. We're using meshes now. We don't need no triangle. This we don't need anymore. Okay, so we just load the mesh, right? And then there is now no longer a pipeline here. Instead, in this case, if we want the pipeline, we can just do mesh. Well, in this case, like get pipeline, although again, we need to obviously support more than a single pipeline. And pipelines we use in OpenGL as well, so this is very much not Vulkan specific. And a pipeline in OpenGL also contains the vertex attribute layout because it has the vertex array in it. And that's my little abstraction for that. Okay, so now we're taking the pipeline from the mesh, which is mesh pipeline. Can we just do like .as? I don't think I support that in my ref class. Let's make that, I don't know why we don't, to be honest. So if we just add a little function here called template type name t, and we just make this ref t. T is the super thing. T2. Ref t2 as return ref t2. And this should be a const ref t ref, right? Yeah, so this will make everything a lot better, I believe. We can use const for that if we want. So instead of us doing this stuff, we can basically replace this code with .as that. Right? Done. Maybe. Oh, we deleted that, never mind. But that would have worked. So, because we obviously do that in a number of places, like here, right? So we can just do mesh get vertex buffer dot as that. And that is a lot better. So what's this? A ref of vertex buffer. Why is that? Has it just not compiled yet? That's what I just wrote, right? Oh, sorry. We don't need this. That's just instance. My bad. There we go. All right, and that looks much better. Yeah, so we in this case we actually get the pipeline from the mesh like that. Let's get rid of that. Yeah, Vulkan pipeline. We can just do mesh get pipeline as Vulkan pipeline. Then we can do that if we want. And then this again is dot as. Take that away. Where do we do the... Here it is. So this is us doing, and this can be done anyway. In fact, let's do this maybe outside. Let's do this outside build command buffer, because this is something that you would have inside on update, right? So you update the camera and then you update the uniform buffer. So actually when we, okay, sorry. Let's backpedal a little bit. I still will do that there because obviously we don't know what shader we're using. But build command buffer, I'm gonna change this to like render, and this is gonna be like the renderer's command now, right? So this is like the renderer we're emulating. So what do we want? We want the camera. And I know we've got that as a member, but again, like I'm trying to pretend that this is in another class. So when we do this, we'll call render, clear color, and camera. And then we can go into the camera and get the view projection from there, which is not const very strangely. Yes, it is. So why are you a hater? Oh, that's not something, that's an editor camera specific thing, really? That's why we use scene camera, I think, and we convert it. Anyway, whatever. Because I think cameras don't have a view matrix. Because cameras, obviously in a game, like with an entity component system, cameras have, cameras are part of an entity that has a transform component, and the transform component is the inverse of the transform component is the view matrix for the camera. So you don't take it from the camera, you don't store it. So that's that, and we can now set that. So we assume obviously that the shader has this 0 uniform buffer at binding 0, which is the camera. That's fine. Okay, and now this is the other Vulkan code that we need. This stuff, so how does this work? Well, the mesh should contain materials. And again, this is something that like how is this supposed to work, right? Like, it's kind of difficult because how is this supposed to work? Like, we need to either set this on the material, which is tough because we don't normally do that. In OpenGL, everything's very like last minute, right? You can just be like, I want to render this. And by the way, bind this texture. Whereas that's not how Vulkan works. It needs a descriptor set up front. So in order for that to happen then, yeah, and this is all kind of okay, I think. Let me close my door. So does this work now, actually? Because we're getting the... Let's try this, because I think now we're actually... The pipeline is not... We're not creating a pipeline for it. The mesh is creating a pipeline for it. And I'm seeing a lot of errors. Which is typical. And let's see. Okay, M instance. Maybe that's not what I want. I guess I just want this. Technically. Alright, so that's all good. I expected it to be because we didn't really change much, but now, yeah, so the way that we set this stuff up, again, because, okay, so this is where it gets a little bit more complicated as well, because part of this data is actually from the renderer, right? So like this uniform buffer is the camera. It's the camera's uniform buffer, right? So that's obviously being set by the renderer or by the scene renderer. But these two things are kind of images that we need to get from the material that is part of the mesh, right? But also, like, how can we just update these whenever we like? I don't understand. Because it's called VK update descriptor sets, right? And then also, does this belong to something? Right, descriptor sets. Oh, hang on, no, I forgot. So yeah, so a descriptor set, that's just used here when we decide to render it. And a uniform buffer, the way I see this is this uniform buffer here, right? So this uniform buffer is like the camera uniform buffer, should be owned by renderer, right? So the renderer should just be like, hey man, look, I need to give you like a view matrix and probably like an inverse view matrix or like a projection matrix, all this stuff. Get that here, but then this stuff, these are like material samplers, right? So this should be owned by the mesh. So we kind of have this division here. So we're trying to create a descriptor set that has that, but then also that. So what we could do, right? Because this could obviously be completely dynamic, like that, right? Let's make that compatible here. So if that's the case, then every time we create a mesh, we can probably get a descriptor set. We can probably create a descriptor set, or maybe have some kind of cache so that we can look into there and see, hey, do you have exactly the descriptor set I need? Because if so, just give me that, right? But ultimately, we can, every time we create a mesh, we can have a descriptor set, and we can probably ask the renderer, hey renderer, can you please give me your descriptor set? So it'll give us this one, and then I'll be like, also this shader has a whole bunch of stuff. And then we can also be really pedantic with validation and make sure that like, hey man, you have two things that are binding to 0, you can't do that. But I think that's probably the best way to do this, right? Let me just fix all this stuff up. Because we changed the API and made it slightly nicer. I don't know, does that make sense, guys? So in that sense, we need to have some sort of descriptor set here, right? And again, this might be something that I do here, so we can do like ref. I don't know. Do we really want like a descriptor set? How should we store this? And what is the OpenGL equivalent of this? I guess in OpenGL, the way that we store this stuff is simply on the material, actually. Because I think that we have a material, right? And a material instance has a uniform storage buffer as well as a list of textures, which is kind of the same because these are also correspond to texture slots, right? So we have get resource, and we also have bind and bind textures. And bind textures, you can see, literally binds each texture to the slot that's inside that vector. So I think the equivalent in OpenGL is basically we just have a material. But I think we might need to insert something in the middle. And inserting something into the middle would be probably some sort of like, we could even call it a descriptor set or a descriptor. And then that would just let us, and then obviously and what that descriptor would be, let's think about what it is then. What it has to be, honestly, is just, hey, I want to know, like, you know, the shader has a uniform buffer and 2 image samplers. You need to sort that out, man. I need to know what to do with that. I need to know what data to bind to those resources. We could call it like shader resource or something. So you're planning on supplying a descriptor set per uniform or texture. A descriptor set should be supplied per material, really, the way I see it. But the thing is, it's like, it depends on the shader, right? So like if I have a shader and I say, if I've written a shader and it has like 6 image samplers and this huge uniform buffer and, I don't know, push constants, which aren't part of the descriptor set, then like that, you know, you need to set that data somewhere. So it's kind of up to the shader as well. But the thing is, these specific descriptor sets are your bindings to the resources. So clearly that's like that's someone who's using the shader, someone who wants to render with that shader needs to come in and say, hey, you know, these are my textures and this is my uniform buffer. And whether that be different or not, because like, as you know, the renderer has to have some part in this because the renderer has to supply this. So that's why the way that I see this at the moment, and it probably is per shader, the way that I see this at the moment, honestly, is it should kind of be per material, but you could probably do something like renderer get descriptor set, renderer get descriptor set for a particular material or shader, right? So we could even say for this shader, right? And then we could have some kind of hash like lookup or something, and then that would give us like some kind of, that would honestly give us, I think, any descriptor sets that are mandatory for that shader. So in a way, it would give us this, right? It would give us this, and then we would be like, hey, you know, for this material or whatever, you know, I need to supply some other stuff. So obviously this mesh that we load here, Like, I mean, it's a little bit responsive. Like, we check to see, hey, do we have a shininess thing? Do we have a normal material, a normal map? Do we have a diffuse texture? But the thing is, the important thing, I guess, is that at the moment, you know, it's tied to a particular shader. It's tied to the Hazel PBR shader, or the animation one, or the static one, depending on whether or not the mesh is animated. So in other words, like, we know what shader it supports, right? So we need to basically say then that if we have those textures present, we now need to bind them. So I think that what this should do, and again, I guess it doesn't matter what order the descriptor sets are in. So we could just like, we could probably have our own little like vector, and then we could also like, you know, append this vector to it. But honestly, I just feel like we'd have this here, right? And then when we come across like a texture, then we could just say like, I mean, here we're setting like normal texture, and then we can actually find the texture slot from shader reflection. So I guess this would be very similar, but instead of doing this, we would just say, I want to create a descriptor set. We could even ask the shader to create a descriptor set for us, right? Maybe that's worth doing actually. So the shader could create a descriptor set for us because the shader knows the binding point of what we're asking for, right? And clearly in this case, it used to be just something as simple as, you know, normal texture. So the equivalent of this, I guess, would be potentially shader get descriptor set normal texture, right? We could do something like this. And then this would give us back a VK descriptor set, like, right, what is it called? A descriptor set, a right descriptor set, right? So this would give us back this, right descriptor set. And then in here, we could come in and be like, hey, WDS, we're going to set our, and then obviously we'd have to make this platform like API independent and stuff, but we could be like WDS dot p image info, right, equals this texture. You know, get, I mean, what did we used to do? It was like texture dot as Vulkan texture 2D, and then, you know, get something. We need to include that. Anyway, Vulkan texture 2D, and then get Vulkan descriptor info, right? And then we could, so we've got that, right? We've set up our descriptor set, and now what do? We just do write descript, or just descriptor sets, you know, push back this, and that's it. And we have to do that for all of our resources. That's how I see this working out. Now, I don't know how this is going to work cross API, because clearly, like with OpenGL, we don't need any of this, but we could still do it, obviously. We could still have some kind of, because what the descriptor set is, at least to me, with my very limited experience with Vulkan, but what a descriptor set means to me is it's a binding between a shader resource and the actual like resource for it. So if I have something in my shader, whether it be a uniform buffer, a combined image sampler, whatever, that's a resource inside my shader. Now I need to give it, I need to create a binding between that like resource declaration, you could say, and the actual definition. So what is the resource that I'm binding here? So that's how I see it. And that's kind of what materials are in a way. So we could obviously have some kind of intermediate thing where it's like, hey, this is a shader resource binding. We could even call it shader resource binding. I almost think that we have, no, we have shader resource declaration. We have a very similar thing in OpenGL actually, like that I've written without even knowing it. But we could have that situation going on pretty easily. And then I assume we can update this whenever we want, right? I mean, what if I decide to say that, hey, I want to change my, can I just recreate a descriptor set? Like if I want to change, like this mesh used to have this albedo texture, but now I want to flip it to a different albedo texture. I guess I just rewrite the descriptor sets, right? And then I obviously bind the new ones. I don't see why that wouldn't work. All right. So in that case, so in that case, what do we need? And then obviously we could basically do like renderer create descriptor set, but that's a bit weird, isn't it? So where do these write descriptor sets go? I think they actually go into the descriptor set. Like that's what this is, right? Update descriptor set. Oh no, we just kind of update them. But what is it updating? What's the descriptor? Oh, the no. Ah, there's the descriptor set. Ah, okay. I might have to re-architect this a little bit. Because here, we're getting the descriptor set from the shader. Which is probably not what we want to do. Yeah, so this, allocate a new descriptor set. So we really should probably ask the shader to do that, I think. So we'll make a function. And I guess we'll do this Vulkan style for now. This is just called create descriptor set. But here's a little bit of a problem. We need to do this on the render thread, don't we? That's okay, I guess, because we can create the descriptor sets on the render thread as well. So we'll just call it on the render thread. So this function is just going to do this. Where's the device? Dust around, welcome. Glad you catch the stream for a little bit. It's always good. Yeah, so instead of this like allocating a descriptor set here, which is currently what it's doing, this should probably like return one, right? So vk descriptor set. I think that's a handle actually. And then that way, so what are we trying to do here, really? That's what we're binding, and then that's, okay, I see. So, what we're kind of doing here is doing, once we have the shader, we basically, like, so this is a Vulkan, let's just get it as a Vulkan shader for now. So this needs to create a descriptor set, and then that descriptor set is the one that we want to update and set up. So we can get descriptors. So this is a write descriptor set. So this isn't really correct, because we actually should be getting it from the shader. We should be creating a new descriptor set in the shader, and then the renderer should just give us its details for a particular shader. Yeah, it's a little bit iffy, isn't it? But And basically that's going to enable us to do this. Right? Because the descriptor set is now this descriptor set. And then everything else here is pretty self-explanatory, I think. We can call it get right descriptor set. Sounds a bit weird, but anyway, so those are the shader ones. Sorry, those are the renderer ones for a particular shader. Actually, you know what? We can do this at the top. Because why are we creating our pipeline here? I mean, oh, I guess because we need the vertex layout. But the shader, we don't have to do that there. We know what shader we're using. Oh, but really the shader should probably come from materials. It's just that it doesn't at the moment because we basically render everything using a single shader in Hazel. Whereas it should probably be some variety of shaders. So we really do need to go through every material then, right? So how would this work? So if we go through the materials, yeah, so the material system is going to complicate things, I think. All right, well, let's pretend that we're still doing what we're doing then for now. We won't upgrade it. So if that's the case, then this can go up here. And in this situation, this descriptor set, and actually all of these descriptor sets, can go here. And so now that becomes that. And these are our kind of like right descriptor sets, right? And then yeah, and we've created a descriptor set. Which is good. And then these are our right descriptor. And we've gotten the ones that we need. Ooh, Kiwi Starkey 3D. Thank you for the Prime subscription. Welcome to the stream. Hope you enjoy your time here. Yeah, so we've got the ones that we need, and then all the other ones, right? We want to be able to create. So this goes into right descriptor sets, actually. So that goes into that. And then we create a new right descriptor set based on like textures that we may have and stuff like that. And they'll have, this is getting like the binding point of it. Yeah. But really this will give us like the right descriptor set, yeah. And so this will give us like, you know, what kind it is. But then it's up to us to set either the buffer or the image, depending on whether or not it's a uniform buffer. But then again, that will be set actually for us by the renderer. Well, at least the uniform buffers should be set for us by the renderer. The only thing we really care about is push constants, which are also set by the renderer, and that's probably from the material system. And also the actual images and stuff. And the images or the textures are set by us from the mesh class, so that's also fine. And then it's stuff like, so that needs to be an actual, that's a resource that actually needs to be created as a descriptor set. However, everything else we have, like for example, if we're using an albedo color instead of a, texture, then that gets set onto the material, which goes into a constant buffer or a push constant. Thank you, J Modarelli. Thank you for the Prime subscription. Welcome to the stream to you too. Yeah, the skybox, J-Gra, the skybox is different because the skybox isn't a mesh. The skybox is just a full screen quad, so we just do render up, submit full screen quad, and that's it, and we actually do that stuff manually, whereas this is like for meshes. So all the meshes at the moment go through the same shader. Which obviously is not gonna be the case in the future. But that's just how Hazel works at the moment. Okay, well, let's try this out. Even though this is going to be pretty Vulkan specific, I guess that's probably the best way to do this to begin with. We'll just pretend that other things don't work. Or that other things don't exist. So get descriptor set, right? So this gives us a vk right descriptor set. Const scd string name. So because we're likely to ask for this, I think that it makes sense for us to, because we actually have descriptor sets here, right? How do we store them? Ooh, I don't think we do have descriptor sets. Oh, well, this is a right descriptor set, isn't it? So how are we supposed to... So I guess if we ask for a descriptor set, we better know, like, what's up by name. So... So I could cache that like that, right? That's a pretty cool way of doing it, I think, maybe. And so what that means is that when we actually like allocate these uniform buffers and we go through all of these, we know that, hey, we might need a descriptor set for that. And so since we might need a descriptor set for that, then let's maybe like deal with that. Do they have a name? Because we want to refer to them by name. I mean, we don't have to. We can refer to them by binding, but do they have the same input elements? I don't know if you're talking about the skybox and other stuff, but no. That's got a different vertex layout. It's just got, I think the skybox, us rendering the skybox just has probably texture coordinate. No, I don't think it has texture coordinate. It's really just got a position, maybe. It's just got a position. It's just got a position. So it is quite different, yeah. Guess it's still technically compatible, probably, but anyway. Okay, so here's the thing. So we do the reflection, and we get the name. Yeah, do we really want to refer to these by name? Well, the thing is, if we don't refer to them by name, then we have to mandate that every shader is like identical. As in, like, normal textures are always in binding slot 5. Like, I don't want to do that. I think by name is probably the best way to do this. So in order to make that happen, and we can still make that happen, I think that we just need to make sure that we'll just store the name. So over here, we'll make sure that we have a name. Again, I know this isn't technically the most efficient thing you could do, but it's also a per shader situation, so I'm not too worried about it, to be honest. But if we get that out, then we can obviously set some other stuff for it, such as descriptor type is going to be this, right? Descriptor type is going to be that. What else do we need? A binding we can set as well. I'll just set it to this, just in case we end up refactoring stuff. Actually, let's go back and just see what we need, right? So, oh, we need to set the S type as well. The count, the type. I think did we set the type? We set the type. The count. The destination binding. And the destination set. Oh, the destination set we don't set yet, actually. That gets set later. All right, that's it. So we've got that now, and then we'll do the same thing for uniform buffers. So this gets set to uniform buffer name. And then everything else is the same. Cool. Maybe we can deal with that a little bit differently later. Anyway, and then I guess all this needs to do, so get descriptor set. we'll put an implementation here. This just needs to assert, first of all, that m descriptor, what do we call it? Right descriptor sets. So m right descriptor sets find name doesn't equal right descriptor sets. So we make sure that something is actually there with that name, and then if it is, then we just return right descriptor sets at name. And this is a const function that will copy the descriptor set. That's the whole point. So it's not gonna, this is not gonna be something that we affect. We're gonna copy it. And then that way, and then we'll have to copy it, and then inside mesh, so I'll have to include Vulkan shader. So this is like temporary Vulkan includes. This is while we figure this stuff out, and also to make sure that everything's going to work before we start abstracting stuff away into platform agnostic stuff, or other render API agnostic stuff. We're going to chuck in Vulkan shader, and we'll probably need pipeline. And we definitely will need pipeline. Okay, so back up here then. When it comes time to do this, we can just do, okay, shader. So what's the deal with our shader? It's pipeline specification dot shader. Okay. So this is pipeline specification dot shader. Get descriptor set. Get right descriptor set. Oh, sorry. Dot as Vulkan shader. Okay. Music has stopped. It's not what I want. So now that we've got this, we can set this, but we also need to actually set the descriptor set. So we should have created a descriptor set. I don't think we did. Or like at least we did it later, which is not what we want. I don't know, we moved it up top. No, this isn't it either. So we're supposed to create a new one, I think. Oh, there it is, descriptor set, we already did it. My bad. Oh, we need texture as well. So yeah, so since we do that, we actually need to set the descriptor set. Where? Destination set, I guess. Yeah, so this needs to be set up. I don't know, maybe we can abstract that. Probably will do that. Vulkan texture 2D, or just Vulkan texture. And then Vulkan texture. Okay, so what's that upset about? So what is this? Get Vulkan descriptor info. Descriptor image info. No, okay, we can just do that. Doesn't matter. All right, and that should be us setting the normal texture. Simple as that, right? So we've got a right descriptor set for that now, assuming it exists. That's the other thing. So does the shader support a normal texture? Get descriptor set is gonna assert at the moment if it doesn't, but maybe there could be like a thing where we could be like, sorry, no descriptor set for this means the texture doesn't support what you're trying to do. Sorry, the shader doesn't support what you're trying to do, which also is, I think, fairly reasonable to do. So let's do that for albedo as well, so we can maybe test to make sure that that stuff works. Right, so we'll just do, this is called an albedo texture. Everything else stays the same, right? We just use this texture instead. That's it. Pretty easy, actually. I like this API so far. But yeah, we also need to make sure that we get the appropriate descriptor sets for the renderer. So what this would do, technically, right? Let's emulate this. So, example. So what this would do is basically give us a descriptor set that would do this. Because we know that it's a uniform buffer. And then also it's up to the renderer to provide us with this as well, right? So in this case, where do we get this from? So it's from the shader at this point in time, which, you know, is not really correct either. As Vulkan shader, you get uniform buffer. I think that's the uniform buffer. What does that give us? Auto uniform buffer. Like that. Okay. And the cool thing with this, and then obviously we have to create it. So we create the pipeline here. I guess, do we need the descriptor set before the pipeline? No, not really. We need to actually create the descriptor set. Or rather, we need to update the descriptor sets. So that's what this does. Update descriptor sets. So we've now basically moved this into the appropriate place. And so in order to update the descriptor sets, and I'll have to do like render or submit stuff, probably. Well, definitely. So we'll copy that for now, which obviously isn't ideal, but it's just demo code anyway. What do we need? Context? I guess context contains device, that's fine. All right, awesome. So, and then that's it. Like, I don't think anything else needs to be done on the render thread, probably not. Yeah, so this is interesting, isn't it? Let's see what we do here. And we're probably not going to get up to this point because I know it does a lot of other stuff, but let's just hit F5 and see what happens. Actually, we don't have textures in this place, do we? In this model. And yeah, no, we don't. So let's go back to this. Okay, I think we had some errors. No, we didn't. Why is the renderer submit? What does it do? Renderer submit submits a renderer command, or like some kind of lambda, some kind of code, to the render command queue so that it gets done as part of the render command queue evaluation. So we don't do that. We don't run that code straight away. We run it on the render thread. We don't have a render thread at the moment, so it's just a queue, but it's the same thing. Okay, we have a little bit of an issue here because descriptor pool object is cd. Okay, yeah, this makes sense. This is where it's a little bit tricky to do this stuff because this stuff needs to be done on the render command queue. Which I think is fine, honestly. I'm trying to quickly in my brain work out if that's gonna cause any issues. Probably not, to be honest. Yeah, I don't think it is. So we obviously need write descriptor sets, right? Where do we get that from? We get that from the we get that from the renderer. Write descriptor sets. It's kind of dangerous to do that stuff on the, yeah. So here's what we're gonna do. We just need some kind of storage for it. So we'll say, we'll put that here for now, right? And then we'll basically move this stuff. So shader create probably hasn't happened yet, which is fine, I think. But we don't have a pipeline yet. We'll see what happens here. I don't think mesh is a ref counted either, are they? No, they are. So there's hope. Shader. Och, my pie. Och, my pie. Thank you for the 1 month subscription. Welcome to the stream. Probably don't need to be doing this so many times, but anyway. So that's there now, right? This needs to go on the render command queue as well. Descriptor set, because we create it, okay. What's this? The albedo texture? So the normal texture does the same thing. Except it's obviously called that. Why are you not working? Write descriptor sets. So that's instance write descriptor sets. Okay. Putting a breakpoint inside here, and let's hit F5. Once we get this working, the stream is over, and Vulkan Week is over. Because as far as I'm concerned, we're done. I mean, we're not done, but it's a start. What? Okay. Isn't that annoying? We're not allowed to include it. We're not allowed to include it inside mesh. Because if we include it inside mesh, then the client needs Vulkan. Because client obviously includes mesh, because mesh is a client-facing thing. Yes. But we need this stuff. I mean, are they both handles? No, this is a struct. Okay, well, what do we do, guys? It's so annoying. I mean, I know this is dirty, but we're just gonna leave them here because we technically only have one model anyway. And to be honest, we could reuse this. But yeah, this stuff will technically be abstracted out into render API agnostic stuff, so don't you worry. It'll all be okay. 5. See ya, Clayfee. Good night. What? Oh, sorry. I never removed that include. Silly. Oh, something to do with our maps not working. This stuff. See, the thing is, like, I don't care about this. It's just I re-enabled materials, that's all. And see, like, if I'm probably going to use this everywhere, or maybe not. Let's quickly disable that stuff. Let's see what errors that causes. That's it? Nah, can't be it. And the metal and stuff. Cool. I think we're just trying to load the actual images now. Now why did that not load? What's the path? Assets, meshes, Cerberus, textures, Cerberus a.tga. Oh, that's because they're not TGA's files anymore. And that's what's unfortunately in there. Ugh. How do we fix that? Do I even want to fix that? Oh, you know what might work, actually? Oh, but it's an animated mesh. Huh. We might have another Cerberus. Cerberus materials. Let's just try that one. Oh, we're still doing this stuff, but it doesn't matter. I'm just trying to get up to my breakpoint for now. That's all. No stream on Monday. I don't know. Next time we'll probably stream. This is going to be in a week and on Friday morning. So kind of like the same as when today's stream initially started. I think is probably when the next Vulkan stream is going to be. Okay, so this just wants I think the problem here is that it just okay. This should be pretty easy to solve. We can just do so like I'm gonna delete this and this. It's alright, they're in Git. And I'm gonna do that. So now they've got the alpha channel ones. And then the two other ones I think will I'll just return from them if I want to. Because it will probably try and load them. So these are the ones that I pushed. Yes, I'm gonna push it into the Hazel dev. There's a oh, and it's actually failed. That's fine. This is the roughness one. So let's just we'll just do this for now. We'll dash coin code. Yeah, there's a branch inside Hazel dev called Vulkan, which I will commit and push this code to. Absolutely. Just gotta finish up as soon as this stuff will work. Okay, we get a little error because VK image object is that. Okay, where are we trying to do that? Oh, we're trying to destroy a Vulkan texture. Okay. Oh, and this isn't even going through render or submit, which it should be. Decref, and that's inside here. Yeah, because that's not even, okay, let's not load roughness textures for now. That's weird, that was never being set into, oh, it used to be set into the material, but it's not anymore, obviously. Guess we can just do that. Oh, that's our code. What? Didn't I disable that? Oh, I didn't. Well, that's weird. Should have. Just trying to get up to my breakpoint. What are my thoughts on modules in C++ 2x or 20? I don't know. I haven't looked into them too much, so I don't really have an opinion yet. We didn't find it. Albedo texture. Oh, that's actually to be expected, surprisingly, because inside our shader. Good. So we're getting up to the shader now. That's nice. So inside this, it's just called U texture. So let's call it U albedo texture, and then I think, what's the normal one called? The normal map is called U normal texture instead of U normal map. That should be it. Delete our shader cache. Really? U albedo texture. And it's got no name. Huh. Well, that's weird. What's this in? Write descriptor sets. Very strange. Should definitely have that in there. Unless the name is wrong. Shouldn't be. Oh, the name is empty. Am I not? Ah, man. Just not actually getting the name here. Where's my uniform buffer? Am I doing it for the buffer? No. Okay, this should be better now. Awesome, we got to our breakpoint. So let's look at the descriptor sets that we're supposedly trying to write. Oh, please, debugger. No, of course it didn't work. Somehow our image, yeah, and I couldn't debug anything, unfortunately. So that made things harder. Did we set everything we needed to? Image info we set. There's probably more. Is there more that needs to be set? Wait, get Vulkan descriptor info. Yeah, that returns a const reference, which we set into there. That texture should definitely exist. Wait a minute. That texture is not going to exist. That texture's probably been deleted. No, but I mean it's saved here, but let's just push it back here just to make sure, because I'm pretty sure it used to get pushed into the material and that's how it stays alive, but I don't think it does that anymore. Well, I mean this sets M textures I to texture, whereas this didn't do it. Where does the I come from? Oh, for the material. We'll just push it back. So that may have been the problem there, actually. Maybe the texture gets deleted later on by the time we write the descriptor set. Yeah, I could see that happening. Oh, good. We got up to here. Sweet. So basically, guys, we don't need this at all. This is it's gone. You have 0. As far as I can tell, that's just outie. That's it. We just load the mesh, then we render the mesh. Where do we get the descriptor set from, though? We get it from the shader, so that's wrong. So we should be getting it from the mesh, right? No, where did we create it? I guess it's, yeah, I guess the mesh, right? Because the descriptor set is, I think, just S descriptor set or something like that. S descriptor set, right? So we need to get that now. Now, unfortunately, the mesh isn't really happy with descriptor sets because it's not Vulkan-ified. So we need to actually hacksaw our way into that, I think. So we could just do like void pointer get descriptor set, and then that would return memory address of S descriptor set. And then inside our test layer, instead of shader descriptor set, we do, let's get a reference to that maybe. Well, it just needs a pointer, so let's keep it as a pointer. And then we'll just do mmesh, get descriptor set, cast that to this. All right, now will we see our little gun rendering with textures now? Because if so, that's pretty exciting. Nope, not quite. Oh, VK update descriptor sets has never been called. Oh, no, I forgot about that entirely. Hold on. I did the write, right? But I didn't do the update. What did I do? I did update. No, I did update descriptor sets. I mean, I can't really see what it's doing, but... Wait, is it oh, it's probably copying it. Do we even need instance? No. Well, this should be referencing it. This should be capturing the lambda. And actually all of these things should be, right? I don't know how they roll, but... Can we... How does static stuff? Yeah, it doesn't get captured at all, does it? Let's see how many we're doing, because if we're doing 3, then I guess it is working, but still a little strange, I guess. Almost done. Two descriptor sets. Okay, well that's probably the issue. Unless it just doesn't have a normal map. Is it not doing the uniform buffer? Oh. Pff. Yeah, good one, Chono. So this should be going into... So this is like our example, actually. So, but realistically, it should be going into the descriptor set. So, what do we do for this? So we push it back, right? We get a descriptor set and then we push it back. So, I guess what we should be doing, VK write descriptor set, right, descriptor set. This is our uniform buffer one. So we can do that, and then we can do S, right, descriptor sets, push back. That. I mean, there's a number of ways we could do this. It doesn't have to be this way, which is in place. Probably be better, but it's temporary code anyway, I don't care. Cool, and that's got a binding of 0, because we know that. But again, this is something that we would get from the renderer, like this, most likely. See ya. Oh, can you please work? Okay, it's trying to do 3 here, but it didn't work out. And I can't debug this for some reason. Why not? Like, it's static memory. It should be the most debuggable. Wait, yeah, the destination binding should be set. The type should be set. It's not saying what's wrong. And this just looks like it's an actual error in reading the right data. So it's as if it didn't actually push it back, which is odd. Because it should have. It should have done that. I'm starting to suspect this a little bit. Sometimes it's weird. Weird. I don't know why that's not working. It should be. I think we're doing the same thing as before, unless I just made a mistake in the shader. But like descriptor type is correct. We're sending it back here. The binding is being set. Current was that. What's current? Now where is this crash happening inside? Call stack. Validate struct p next. Ah, I know what's up. It's because we're not yeah. This should be null pointer. We should actually probably not do it this way, because this doesn't initialize it properly, I think. I mean, we could do set equals that, I guess. That should initialize it properly. That's probably the issue. And then I guess we should do the same thing and like we'll make sure that this does it as well by doing that. Okay, good thing we read it. That's probably the issue. We did it. That's perfect. So check this out, guys. We are now automatically loading a mesh. It's pink because of our push thing. Let's change that. We are now automatically loading a mesh, automatically getting the textures required from the mesh FBX file itself, setting up all the descriptors based on what the shader supports, and rendering it without anything from the client at all. That's amazing. All we have is this render function, which again, might as well live in the renderer. That's amazing. That's really, really good. Well done, stream. We did it. Let's get rid of the pink. Let's just tint it white. Yep. Chono excited emoji. That's really, really good. And we don't have any validation issues or anything like that. Yeah, we're full on rendering, like properly. And all the descriptor sets and all of the like resources are being handled automatically by the mesh and by the shader and by the renderer. So yeah, that's awesome. Check that out. We're doing that really stupid lighting that I just did with the dot product. But anyway, I guess it works. Cool, that is cool. That is very cool. We even chucked in a normal map for fun. No MIPS yet. Lots of problems, clearly. But, you know, we're absolutely not, don't have any errors whatsoever. That's a little asimp red thing about, like, shininess, strength, being whatever. I don't care about that. And yeah, and these actual things are all coming in from the FBX file. Roy, thank you so much for the 300 bits. It is in fact a celebration. Isn't that nice? Alright guys, that's going to be the conclusion of Vulkan week. We got a lot done today. We basically went from 0 Vulkan code in Hazel and not even SPURV running correctly to the fact that we can now compile our shaders once for both OpenGL and for Vulkan. We can sort everything out automatically using reflection, and we created the whole Vulkan context device, the whole swap chain, everything is now working perfectly, it seems. And of course we're still doing some like Vulkan code in places that shouldn't be there, but that's to be expected. But the point is we're now rendering 3D models And in fact, we can even render submeshes and all that stuff inside of Vulkan, or rather using Vulkan. And everything seems to be working correctly. And I think perhaps most importantly, I am Stevo. Thank you for the subscription. Oh, actually, this is CXGS Legend. I can't see it on the overlay. But thank you, CXGS Legend, for 5 tier 1 community sub gifts. Thank you so much for your support. Yeah, he's getting up there. I just want this to disappear so I can see how many. He's on 14 sub gifts now. I mean, no one's gonna beat CA Viper, but CXGS Legend is also very much appreciated. Don't you worry. Anyway, yeah. So most importantly, I think though, this week has just taught me a lot about Vulkan, like a lot about Vulkan. And in general, like I think I understand much more about how to architect Hazel's renderer, which subsequently, remember, I was going to do the renderer rewrite. So now that this has happened, that's really useful, actually, honestly. Because now that's happened. Tulaboy3, thank you for the Prime subscription. Thank you guys so much for your support. I really appreciate it. Now that that's happened, I have a much better understanding of Vulkan and like just how Hazel's renderer should go going forward. So I'm super excited about that. Obviously, still lots of stuff we need to do. The hype train's great as well. Lots of stuff we still need to do, such as you know, things like frame buffers, things like cube maps. Like there's lots of different things, but it doesn't matter because we've got the basic understanding of how to render stuff in Vulkan. Everything else is just extra stuff that we need to add to our command queue or to our command buffer, and everything kind of, you know, everything kind of works. And that's, like, to me, that's important because I realized that everything's that's the important stuff. Roy, thank you again for the 100 bits and a successful little hype train. 500 bits from I am Stevo, thank you. Wow, you guys are so nice. It's almost like you want Vulkan Week to continue. I thought everyone was happy that it's over. Toolboy converted from Prime Gaming sub to a tier 1 sub. I don't even know what that means, but thank you. Oh, did you guys enjoy Vulkan Week as much as I did? I don't know, this was fun. Like, I mean, we had some problems, I won't lie. And like, I am definitely exhausted and tired from like streaming like all week, but I think things got better. I think the first 3 days I was a little bit like, I think I wasn't looking after myself too much. And then I started going on like daily jogs and exercising a bit more and relaxing, actually ending the stream a bit early as well some days just to relax. And I think that did wonders because if you watch the streams from Monday, Tuesday, from day 1, day 2 versus like, especially yesterday, day 4, and today, I think I'm like on fire compared to that. So I think it's really important. I'm gonna make a little Hazel, there's actually gonna be a video dropping tonight if I can finish it in time. Or start it. But there's gonna be like a little reflection video that I'm gonna do tonight. And I think honestly, my biggest takeaway this week is that like it's really important to look after yourself because I didn't really consider that as much until this week because I was just feeling so terrible on the first 2 days compared to now. Wow, Tulaboy3, thank you for the 5 gifted subs. Oh, that hype train is just going, man. Alright, anyway, yeah, really appreciate all of you guys. I don't think I could have made it without chat, to be honest. I'm not just saying that as well. Like, you guys watching my stream really helped me this week because apart from the fact that you straight up helped me with some issues I was having with Vulkan, I think that the other big difference... I'm gonna call Lisa and tell her that I remember. Okay? Yep. I think that, yeah, apart from that, it was, we'll get to level 5 before I end the stream. Apart from that, it was just the motivation as well and just keeping me kind of focused and like not letting me give up and whatever. So I really do appreciate streaming with you guys. Anyway, thank you all for watching. Thank you so much for all of your support. Remember, you can check out patreon.com/thecherno to get, I'll upload all of the VODs on there indefinitely, so you can watch Vulkan Week even a year from now, and it'll still be up because Twitch does take it away after a while, after 60 days, I think. But, oh, and if you want access to the source code as well, I will be pushing it to the Vulkan branch of the Hazel Dev repository some point later today, for sure. Okay, because it's working, and I really need to push it while it's still working. Anyway, thank you all. I love all of you and appreciate all of you. And I will see you next time. Goodbye.